This short video is going to cover how to take polar graphs and write equations from them. So we're going to start with something simple, which is a circle. And hopefully you guys can see this. And this circle has a diameter of 1, 2, 3, 4, 5 units. And so we can also see that it is along the y-axis. So our equation is going to look like this. So it's going to be of this form: y equals d sine theta. But two things to note is that you have to find your d, which we did. We know that is 5. And we know it's on the y-axis. That's the second thing. So that's why it's sine. But it's on the negative y-axis, so we need a negative sign for our 5. So that's the equation of that circle. The next one is a vertical line. And we learned in one of our previous lessons when we were converting from 6-4 how to go from rectangular to polar and back again. The vertical lines are normally x equals a constant, but when we convert it to polar, we get a secant equation. So what we have to figure out is what r we have, so we can count 1, 2, 3, 4. So our equation should look like this. Some distance times secant theta. So in our case, our distance is 4 units times the secant of theta. Now we're going to skip number 3. For number 3, what you see here is you have 2 points here that you can recognize, but what you need to find this is the point that is closest to the origin. There's a little formula for it, but we're not going to do that one in this class. That's beyond the scope of this class. So the next one then is a rose curve. So you want to notice that it has 5 petals. So that's going to be our n. Whenever you have an odd number of petals, so in this case, n is going to be 5. Now the other thing you want to notice is how it's oriented and the length of the petals. It's always going to be cosine when one of the petals lays along the x-axis, which this does. So we can see this has a petal here along the x-axis. So we know we're going to have cosine theta here. Well, actually 5 theta, because we have 5 petals. And then we need the length of the petal, and we just count 1, 2, 3, 4, 5 units. So r is going to equal 5 cosine 5 theta. Okay, our next curve is a limacin, and it's centered along the negative x-axis. So we're going to have a negative sign in front of it. And we also want to notice that we have an inner loop, so that tells us that A is going to be less than B to get an inner loop, because remember, A over B has to be less than 1 in order to have an inner loop. So what we need is we need our maximum R and our minimum R. So our max R is going to go from the edge of the limacin to the origin. So we have 1, 2, 3, 4, 5, 6. So that's our max R is going to be 6. And our minimum R is the length of the inner loop. So that is 1, 2 units. So what we're going to do is we're going to say that A plus B has to equal 6 and A minus B has to equal 2. And now we just create a little system of equations that we can solve. I'm going to add these together, and I get 2A equals 8. So A equal 4, and that would make B equal 2, except for one thing. Remember, A has to be less than B. And here's where this gets a little tricky, is the fact, remember that when we do these, It's the absolute value of r is our max. So we could switch these around. And since we have an inner loop, we want b to be bigger. So the equation normally looks like this. Keep wanting to write r. R equals a plus b, and in this case, cosine theta. Now, with our inner loop, our a has to be the smaller number, which is 2. B is going to be the 4, and we have cosine theta. And since it's on the negative axis, we need a minus sign there. So that's number 5. For number 6, I don't know if you guys can see this. It's kind of hard to see. We have a circle here. Right there. And so it's centered at the origin, and the only thing we need is the radius. So that radius is 1, 2, 3. So the equation is just r equals 3. There's no cosine or sine involved because it just represents the length of every vector you can write that's 3 units from the origin, so the angle doesn't matter. Okay. Number 7, we have another limacin, but we have a cardioid. So that means, in this case, that A equals B. And it's on the y-axis, so the general form will look like this. Oops. So how do we find A and B? Very simply, we just take the max r and we're going to divide it in half because remember A plus B has to equal r and they have to be equal. So I'm just going to count from the origin to the top. 1, 2, 3, 4, 5, 6. So that r equals 6. So that means A and B both have to equal 3. Sorry, that looks a little bit like a B. So since A equals B and they're equal, that means A and B equals 3. So my answer is going to be A equals 3 plus 3 sine theta. Next one, we have another rose curve, and we have to count the flowers, or the petals, and we have 1, 2, 3, 4, 5, 6, 7, 8. So that means we have an even number of petals, so n is going to equal half of that. So n is 4, because you double n to get the number of petals. And I also noticed that there was no petal on the x-axis, so this is going to be of the form y equals a sine n theta. So I have n, so now what I need is the length of the petals. So I just have to count out from the center. One petal. 1, 2, 3, 4, 5, 6. So my answer is going to be y equals 6 sine of 4 theta. And then finally, the last one, we have a rose curve again. And this time we have 4 petals, which is even. And we also have petals on the x-axis, which means that our form is going to look like this. R equals a cosine n theta. And we know that n is going to equal 4 divided in half, which is 2. So we have an n of 2 since there's 4 petals. And we just need the length of those petals. And we have 1, 2, 3, 4, 5. So A is 5. So our answer is R equals 5 cosine 2 theta. And that's how you work the other way to get the graphs. Get the equations from the graphs.